Hello, my name is Konstantin Ignatov. I work in Curator Labs. It's a DDoS protection company. We research internet as a whole, as a big graph, and we are leader in Russia in this industry. And tasks we are facing are complicated. We are mostly going to talk about today some things that involve complex behavior of people, but we are going to simplify it because it's just a lightning talk. We have only like 5 minutes, I believe, and we are going to look at very simple version of pattern discovery problem. Please raise your hand if you're kind of familiar with pattern discovery, or if you know what pattern discovery is. Okay, one. Patterns are some frequent or maybe important subsets or substrings or subsequences, or maybe even some even harder versions like popular regular expressions that are frequently or in some other way importantly occur in your data set. And your data set is just your database, which is filled with, for example, user sessions or some other kind of data. Let's look for a simple example, like simplified for like 4 rows. Here, ID is just an ID of user session, of a receipt in a store, or anything else. I really try to avoid the word transaction here, but originally authors of most of those algorithms used the term transaction for the second part of the for the second column. So here in this simple example we have 4 elements everywhere. It's not always true. We can have very long transactions, and here we deal with sets. We can mine and find patterns in very different kinds. For example, we may be interested not only in occurrence of some ID or product, but in a sequence in which those products, for example, were bought. So, for example, this could mean IDs like receipt, and numbers in the second column are like product IDs in that receipt. And we would like to know which products are frequently bought together. In this very simple example again, patterns could be very complicated, and probably not every general solution for now can handle it, but let's keep it simple for now. So why do we would like to have it? We would like to, as I said, find frequent set of projects that's usually bought together. For example, the store may want to locate these projects nearby, and we would like to know, for example, how the user behave usually on our side, so we could do improvement in our interfaces and so on. And in this case, is it hard? This is the usual question that comes to the mind. And the answer is for some implementations or some given some restrictions on that question, there are simpler solutions. There are solutions like recommender systems. There are different types of things. But again, if we are talking about really complex patterns like a man going to one store, then going to another store, and buying some things after going to Starbucks and buying something else. And given that those three shops are somehow interact, they may want to find a complex solutions, complex patterns. But again, let's keep it simple. Let's just consider those 4 rows, and let's try to build somewhat. Let's try to mine their idea, the patterns here. Interesting thing is that most of algorithms, I believe, in this field were originally kind of purposed for SQL systems, and authors were trying to avoid fetching data from SQL systems, but mostly they failed because SQL systems were not able to do a lot of functions, and they are not particularly good when you try to read transactions, I mean read the whole database in one scan, in a full scan. But when I see this is a combination like good reading of a full table, like in 1 second, in one scan, and when I see complex functions, complex syntax, ClickHouse comes into my mind and looks like it can handle it. Sort of. Let's start our example, and first thing we have to do, there are a lot of algorithms, we will look at one. This is so-called vertical mining. It's Ignatov, basically, algorithm, if you are familiar with. If it's not, it's okay. What we transformed here, if we on first slide had an idea of receipt and goods in that receipt, here we reversed it. So here we have an element of product ID, and corresponding array is all the receipts in which this element appeared. And basically, if we did a little change here, we are starting to get the answer. So here we get patterns of length 1, which are already part of our solution. In this query, 1 is just support for our task. In this case, it means that we are looking for all the possible patterns, and it's actually easy to enlarge it, increase it, so we have to use much less memory and process it's faster. Well, here we see that we create a table, and we will use it later, and with all other iterations of this algorithm, we will do the same. At some point, we can drop unneeded tables. And this is more hardcore version that demonstrates, on one hand, how ClickHouse is flexible and how good things it can do, and on the other hand, how complex things can get very easy and quickly. Well, how to read it? Well, reading it, as usual with joins, it starts from the end, and the end means something that is most deeply, and in this case, it's select of and group array inside array join. What we have here is we just create an array of original table. Basically, we are trying to do a Cartesian product. And with help of group array, we create array. With help of array join, we add this array to all the rows. And with help with this array reduce and very undocumented, I believe, function of group array, we are creating, cleaning the arrays back and repeating them. It sounds complicated, but in the end, we are just getting the very similar table to what we have on the previous slide. But in this case, we already have elements with we have patterns with 2 elements and corresponding receipts. Eventually, the size of arrays in the result in this second column is our answer. If it's larger than our support is 1, then it's element from first column should go to our answer. Well, if you are not enjoying, if you're enjoying this query, you can look at this one more time, because the next iteration is not going to be different. And really, all that changes here is that we're using previous table, and we are getting more longer patterns. Again, not too much magic if you like sit with this query for like 2 minutes, which I believe you already do. And the last iteration in this case will be the 4th one, where we will try to achieve 4 when we're trying to achieve patterns of length 4, and we fail because there's none. And at that moment, the vertical mining algorithm stops. And we got a result. It just represents counts, and we can see that we have all the patterns we need. Eventually, this is not very efficient algorithm. There are more efficient versions. For example, you can see that probably if you have 5, 4, and 2 pattern, then maybe you don't need to have 5 and 4 pattern, because you kind of have this information already. This kind of mining, when you avoid getting these sub-patterns, is called closed patterns mining. And to do that, you have to kind of do some more complicated ways, more complicated things. You have to break the recursion that hidden was happened here, and you have to disable some branches of this recursion. It simplifies things in terms of computation. It speeds up things, but with ClickHouse, it probably is not possible for now. But probably the most important thing I would like to say here today is that probably today and now we are at that level when pattern discovery, a thing that were kind of a magical for like 10 years ago, maybe, is more than possible, and maybe it should be in some future in more efficient ways integrated into ClickHouse and maybe other DBMS systems. Well, thank you. I think we have 1 or 2 questions.
Thank you. Why don't we leave questions till the end, if you don't mind? Ingmar. Sorry, we are
okay.
a bit running a bit behind. Thank you.